Okay, I am at ETSI Security Conference, and with me I have Ian Oliver from Nokia Bell Labs. Thank you for joining me, Ian, so much.
Hi.
Could you start by introducing yourself a little bit and your background in security?
Okay, I'm Ian Oliver. I work for Nokia Bell Labs in Finland. I specialize in trusted computing, although I've got a long background in hardware security, privacy. I wrote the first book on privacy engineering about 7, 8 years ago and so
Oh,
on.
really?
And then go back, semantic web, UML was my first love, if you like.
Okay.
So a long career.
Fantastic. And this week you're talking about integrating trust and attestation in 5G, O-RAN and edge computing,
Yes.
which I'd like to ask you some questions about. But firstly, just some definitions. So kind of what is a trusted system?
Oh, good question. Okay, first of all, a trusted system isn't necessarily one that's secure, so let's get that out. A trusted system is one where you know its identity and you know its integrity. You know what it is, what software it's running, what firmware it's running, potentially even what hardware it's actually composed of. And just the ability to know these things gives you a certain amount of assurance. So it's much better to know that you've got a compromised system than not to know whether the system is in a good state or not.
Okay, so trust isn't necessarily in a traditional sense that it's secure, that it's safe, but more that you know what it is and...
Exactly. Although what you try and do is build a safe and secure system and then establish cryptographically measurements of that system, claims about that system, and use that as part of the attestation process. Most of the time, typically, we see this in forms of using the Trusted Platform module as part of, ideally, a measured boot, although I'm happy with secure boot as well. Two very complementary techniques. Yeah.
Okay, and you mentioned it briefly there, attestation. Could you just kind of explain briefly what that is?
That's just the process of asking your device to prove its identity and its integrity. Nothing more than that. The actual process behind that might be quite complicated, and the number of questions you have to ask to do that. Things like TPM make this very, very simple to do if you've got the underlying firmware infrastructure to take those measurements in the first place.
And you work a lot with safety critical systems where this kind of thing is really vital, right?
Yeah, I love safety critical systems. It kind of focuses you on how, if these systems go wrong, potentially people will die. So it focuses you very, very much more to think about how to keep these systems safe and reliable. I worked a little bit with railway systems. I've worked with medical devices as well. And you can imagine what goes wrong or what can go wrong if these systems are compromised in any way.
Yeah, of course. So what are the challenges of integrating trust and attestation in these particular systems where it is so vital?
Oh, well, the first one is actually getting systems that even have the capability to report their trust. But let's say you've got a system, a medical system or a railway system that can actually prove its identity and prove what software it's running. The next challenge that you have is being able to distribute your attestation or be able to talk to multiple devices. That's the first challenge, and I think that's broadly solved. We know how to do that. The second challenge then is how do you decide whether a system is trusted? If one component is failing, how do you recover from that? So you've got a lot of these systems. If one component fails, you still have to run the system. So your notion of trust then becomes weaker, if you like. So that's the second challenge. Then there's always the question, okay, where does the trust come from? How do you know you've got that system? And that takes you into supply chain security. And now we're starting to see a lot of movement in software bill of materials, hardware bill of materials, very granular forms of those which we require. Notarization of these, so the ability to communicate, to say, okay, this is what we're going to deliver you. And we have systems like Salsa, Sigstore, and so on, which Google are promoting, Red Hat are promoting for doing this kind of notarization. You could even get into NFTs and blockchain, which is something that we're also researching as well. That's brilliant, but now the next part is you need to integrate that with your attestation. So when you get these components, be them hardware, containers, whatever, you need to integrate those into your attestation process, and you need to effectively close the loop to basically say, okay, now you've delivered me this, I need to check this, I need to prove that it really came from this source, and it really is the thing that you're delivering me. And so that's one half of that. And then we've got the whole forensic side, which is when something goes wrong, how do you diagnose that? And I've got a number of students now actually work on root cause analysis, which again is a safety critical technique, or comes from safety critical systems, for actually diagnosing systems. And that has all sorts of very interesting implications on how we manage these systems, how we respond to trust failure, and so on.
Okay. So I guess what do you kind of do then if the attestation comes back and it says this is not trusted?
Well, we're working on that. Well, one thing I don't want to do is just restart the system.
Yeah.
So in many systems, in a simple system, this might just be acceptable. In many systems, it isn't. In a railway system, you can't just say, right, I'm going to reboot the locomotive. Doesn't work. Not only that, but systems are composed of so many other systems. This whole system. There is no notion of rebooting the system or restarting the system. And even if you did, you're still going to end up with the same problem anyway. So one thing that we're looking at now is looking at things in 5G, slicing, for example, to see how the infrastructure can actually do a lot of this for us. So if you've got a system that's failing, can we use facilities in 5G? Can we use facilities in ORAN to start proactively protecting and sandboxing parts of the system in order that we can put the failing parts or the fail parts in a protected environment where we can more closely monitor them so they don't affect other parts of the system. So it's a compartmentalization approach, if you like.
Okay, because I was going to ask you about 5G, because that's something you're talking about in your talk. And I mean, 5G is being rolled out everywhere now, and it really is bringing a lot more connectedness between people and devices.
Yes.
Does that make trust and attestation a lot more difficult because you've got all these components? Though you were saying that actually that may help you compartmentalize.
Well, yeah, it makes it a lot more difficult because now we have to start worrying about things like latencies. Attestation takes time.
Yeah.
So now we have to start distributing the attestation around, how we communicate the known good values for attestation and so on. And also just getting vendors and OEMs and everyone else to take advantage of the facilities that 5G inherently has in order to protect your system. So again, slicing is the classic example. And as we move into things like 6G, that's going to become a much more dynamic thing as well. So we've got these infrastructures that already have the capabilities to protect the systems and give you a lot of security by default. I guess we're in the stage where we have a system called Attestation, which can very naturally take advantage of this. So they're very supportive of each other. Our research now is really just looking at what this communication between attestation, things like 5G slicing, what we can do in the ORAN side and so on. How do all these come together in order to give you security without you ever having to worry about it? And there's a lot of research to do in areas like orchestration, be it in the 5G, in the cloud or wherever, on how we orchestrate our protections and what it actually means and so on. So there's an awful lot of open questions there. If we manage to answer a tiny amount of those over the next 10 years, I'll be quite happy. But it is a very pressing area, and we've got these facilities, so we should take advantage of them.
Okay, and what kind of role do standards or regulations play in this?
Right, standards. Well, at least in the case of 5G, for example, if you look at the 5G core we have the standards give us very clear areas where we can plug this technology in. Okay. And in areas where that's a little bit weaker, of course, then we can influence those standards. There's a lot of work going on in ORAN now regarding the security of ORAN and what we should have in there. So the standards give us our point of focus, and hopefully we improve the standards as we go along. Regulation. I'm not sure whether regulation makes our life easier in the sense that, yes, now security is mandated, or it makes it much harder because we need to get the security working and integrated. So I'm in two minds about that, but I do like a government entity saying you must have security in the system by default. And, it then again focuses us on actually trying to produce a working solution for them.
You mentioned possible regulations saying they have to have security and by default. Attestation, is that something that is kind of put in at the beginning and thought about, or is it kind of something that comes in afterwards?
Well, it should be thought out across your whole process, and typically this would come from your supply chain processes, your CDCI processes or DevOps, when you produce the software and the hardware and so on. So you should have the necessary measurements, and this might be, again, software or hardware. Bill of materials is a good example. Signed software, the signatures of software. That's effectively the raw material for attestation, and that's what the attestation will go and check against the hardware and software that's actually been delivered. So you need it already in your design processes to take this into consideration. So you must think about this. Whether it gets used for attestation is another thing, but it must be in there, so it's ready to support.
Okay, so it's a very vital part from the beginning.
Absolutely.
Well, thank you so much for taking the time for this interview. I hope you have a great rest of the conference.
Yeah, thank you.
Thank you.
Thanks.